Hey guys, welcome to question MM397 of the Maths Methods Fortify study guide. So in this question we've got a random variable y which has a discrete probability distribution as shown by this table, and we need to find the probability that y is less than or equal to 6 given that y is greater than 0. Alright, awesome. So first things first is we need to recognize our conditional probability here. So the general formula for conditional probability, if probability of A given B, this is equal to the probability of A intersect B over the probability of B. Okay, so let's apply that to this equation here. So we've got probability of y is less than or equal to 6 given that y is greater than 0, which means we've got the intersect of these two things over the probability that y is greater than 0. Awesome. So what is the intersect between y is less than or equal to 6 and y is greater than 0? Well, we've got an equals sign with this 6, so we have to include the 6, but we don't have an equals sign with the 0, so we don't have to include the 0. Okay, so it's everything above 0 that's also 6 or less, which means that this is the probability that y is between 1 and 6 over the probability that y is greater than 0. Or you could even just say like this. Awesome. So this is actually our first mark. So this is a 2-mark question. Getting that formula there gets us our first mark. And now we need to figure out the probabilities of each of these two different things. So we need to figure out the probability that y is between 0 and 6, not including 6. So here we've got 0 and between 0 and 6 are these four here, but we're not including 0, so we can't include that one, which means we have to have the probability of 2 plus the probability of 4 plus the probability of 6, and that's the probability that y is between 0 and 6, not including 0. Okay, so we get the probability of y equals 2 plus the probability that y equals 4 plus the probability that y equals 6 over the probability that y is greater than 0, right? So everything greater than 0 is 1, 2, 3, 4, right? Not including 0, but including these 4. So we get probability that y equals 2 plus probability y equals 4 plus probability y equals 6 plus probability y equals 8. Awesome. So what we end up with is the probability that y equals 2 is simply just this probability here. So we get 0.1 plus the 4, so plus 0.4 plus y equals 6, which is 0.2, over y equals 2, 0.1 plus 0.4 plus 0.2 plus 0.1. What we get is 0.7 over 0.8. And you're not allowed to use a calculator for this, so you need to recognize that you're able to move these decimal points over by 1. Okay, so that is equal to 7 on 8. And that's our second mark. Guys, that's our final mark for part B. If you're not sure about any of it, just let me know. But let's move straight on to part B. All right, part B is a 3-mark question this time, and we're dealing with the variance. All right, so this can be quite irritating to do, to be honest, just because it does take a little while to do, but it's a 3-mark question, so you've got 4.5 minutes technically to do it. So first things first is to recognize that the variance of a variable, so in this case we've got y, is equal to e of y squared minus e of y all squared. Right? So these two are two different things, and I'll show you why in a sec. So let's start with this one because it's probably more easy to work out. So we need to work out what e of y is and e of y squared, and then merge those together within this formula. So how do we find e of y? Well, e of y is our expected value, or our mean, and the way that we find that is by doing our y value multiplied by its probability and adding all of those together. Okay, so this times this, plus this times this, plus this times this, plus this times this, plus this times this. Okay, so what we get is 0 times 0.2 plus 2 times 0.1, so 2 times 0.1 plus 4 times 0.4 plus 6 times 0.2 plus 8 times 0.1. What this gets us is 3.8. So our expected value of y is 3.8. Okay. Now, what that means is that is our first mark. Awesome. So from here, we now need to work out our e of y squared. Right, so we've worked out our e of y, and then we're going to square that later, but we now need to work out e of y squared. So e of y squared is exactly the same thing as e of y, but we're going to square our y values before multiplying them, okay? So instead of doing this times this, we're going to do this squared times this, all right? So in this case, we have 0 squared times 0.2, which of course doesn't make a difference because it's 0 anyway, but these ones will make a difference, plus 2 squared times 0.1 plus 4 squared times 0.4 plus 6 squared times 0.2 plus 8 squared times 0.1. And what this spits out, as you work it out, actually I'll do this bit here. So this is 0 plus 0.4 plus 6.4 plus 7.2 plus 6.4. Awesome. And then all of these added together, which you should be able to do without a calculator, gives you 20.4, and that's your second mark. So we found e of y, we found e of y squared, and now we can put them together in this formula. So the variance of y is then e of y squared, which is this bit here, so 20.4, minus 3.8 squared, right? So in here we've got e of y, which is our 3.8, and then we're minusing that squared, 3.8 squared. Awesome. Now if you need to do long multiplication to get this, or you can do, you can change it into a fraction and square it. Either way, you're just not allowed to use a calculator. So do whatever method you think is the best for that. You could do your 3.8 times 3.8 and then do that. So 8 times 8 is 64. Then 8 times 3 is 24 plus 6 onto that is 30. Put your 0 down there. 3 times 8 is 24. 3 times 3 is 9 plus 2 is 11. And then you add these together, 4, 4, 4, 1. We've got 1, 2 decimal places, so it's 14.44. So we get 20.4 minus 14.44. Oops, sorry, you can't see that. So that's 14.44. And then the final answer is 5.96. That's our third mark. So guys, that's it for part B. If you have any questions about any of this, variance is just a way, it's a measure of spread. Variance is very difficult to define. We don't really use it on its own as a measurement, or as a measure of spread. It's more used to find the standard deviation, which is much more important. So yeah, if you're gonna ask me what the variance is, that's all it is. It's just the measure of spread. Don't delve too deep into it because you don't actually need to know what it really is on a deep level. So guys, that's it. Let's move on to the next question. If you have any questions, as I said, let me know in the comments below. But otherwise, thanks for watching, and I'll see you in the next video.